Good afternoon, teacher. My name is Warakamondra Bangplat, and today I'm going to present you a semester project about columns as structural element in civil engineering. What is column? Column is one of the most important elements of building structure. It was, it was built for supporting beams or columns on the upper floor and transferring loads parallel to longitudinal axis as tension or compression. Beams and columns both take major role in building structure. They needed to be connected and support loads together. However, there's difference between them. Columns' internal moments could be easily influenced by load-induced deflections and increased bending moments, but beams could not. Therefore, designing columns for practical usage should be well calculated. The first criteria is based on loading. The first one is axially loaded column. In this type of column, loads act along longitudinal axis, and it only could carry direct compression. So this type of column can be used in multi-story building and interior column. The next one is eccentrically loaded column, which can be divided into uniaxially loaded column and biaxially loaded column. In uniaxially loaded column, it can be used as edge column, and biaxially loaded column can be used as a corner column. Secondly, based on type of reinforcement, which can be divided as tight column and spiral column. Tight column was generally used as 95% of all columns in the building in non-seismic region, and spiral column is used when high strength and high ductility is needed for building. Thirdly, the criteria is based on slenderness ratio. Slenderness ratio is the ratio of effective length to the least lateral dimension. If the ratio is less than 12, it would be categorized as short column. But if the ratio is more than 12, it will be long or slender column. And the fourth category is based on shape of cross-section. The first one is geometric shape column, which can be divided into rectangular square column and circular column. Rectangular and square column has a low cost and easy casting, so it is widely used in residential and office construction. But a circular column gives smoother and more aesthetic texture, so this type of column is used in higher elevation construction. The next one is L-shaped column. It is commonly used as corner column. Y-shaped column. This type of column is widely used in bridges construction. And the last one is T-shaped column, which has a similar characteristic as square and rectangular columns. The fifth criteria is based on construction material. The first one is wood timber column. It was used for light loads. It could give aesthetic appearance and it was designed for interior such as reception area. The second one is steel column. It was used for heavy loads such as aircraft manufacturing warehouse. And the third one is RCC column or reinforced concrete column. It was used in the most type of building and other structure like tanks and bridges. Is steel frame aimed in concrete for reinforcement. And the last criteria is based on frame bracing, which can be divided into braced frame and unbraced frame. Braced frame have a brace frame in the columns to prevent gravity load, and the shear wall to prevent lateral loads or wing loads. But the unbraced frame has no brace frame and shear wall, so the load capacity of the columns was reduced. And the last one is pre-stressed concrete column. The pre-stressed concrete column can alter a cracked section into the non-cracked and resist major bending. And this type of column works well with high slender column and precast column. The next one is Euler's equation. It is essential formula for anyone who wants to design columns. In this equation, we want to find critical buckling stress, which is specific loads that columns bend. Critical buckling stress is equal to pi square E, which E is the modulus of elasticity, divided by KL by R square, which K is coefficient that depends on the columns and constraints, and L is unbraced length of the column, and R is the radius of gyration with respect to the unbraced length, and R equal to the square root of I divided by A, which is I equals to moment of inertia, and A is equal to area of cross-section. However, Euler's equation still has some inaccuracy. From the graph shown in the slide, you can see that when the slenderness decreases, the result from Euler's equation is significantly more different from the test result. So you can conclude that the Euler's equation can work well with slender column only. And the last topic is how to draw the column layout plan by using AutoCAD. Firstly, you need to choose the shape of column. Then draw the column by using Draw panel and choose the shape of column you want. Thirdly, fix the column location by using Move command. Because the column should be located at or near the columns of the building and at the intersection of beams and walls. And the position of columns should reduce the bending moments in beams. Fourthly, set the grid line by using line command or construction line command. Line command you can entering L on the command line, and the construction line you can enter XL or X line on command line. Next, numbering the grid line by numbering alphabetically in vertical line and numbering numerically in horizontal line. And the next step is set the dimension line. You can using dim linear command by entering DIML on command line. And the last step is set the size of structure inside of column. And that's the end of the presentation. Thank you for your attention.